What's going on, guys? Today we'll be doing Leetcode question 200, number of islands. So it will most likely destroy me, but we will learn in the process. So I'm excited for that. Let's get to it. I go to the iPad. Alright, so now I've submitted it. This is my initial algorithm. I was able to get it to run in 136 milliseconds, faster than 5% of Java online submissions. Not the best. And not the best memory usage either. So now that I've solved it, got it accepted, I'm going to look at the solution and see where I'm at. Alright, what's up, guys? So I finally got it finished. I started this morning, went to work, and then finished it. Actually, I finished it at lunchtime. I took a little lunch break. I worked on it a little bit, so I actually finished it then, but I'm going to do a recap right now. So here's my long algorithm, and I looked at the solutions. Obviously, there's more optimal ones, but I think my solution at least works, and it uses a good BFS implementation. So you can see here it's not the quickest, but it was accepted, which is nice. And I didn't have to have any help with it, which is cool. Typically, when I've done Leetcode questions, I just go in, fail. Within 5 or 10 minutes, I look at the solution, and I'm like, oh, that's how you do it. And then I move on to the next one, and then guess what? The next day, I'll forget the solution that I looked at. But this way, you grind through it, you use your grit, and you use your determination, and you say, I have to finish this problem. Now, obviously, if it takes 2 hours or something like that, then you don't want to continue going on that. But anyways, let me go over the solution here. So I do a little validation up here at the top. So the grid cannot be null, and the length needs to be less than 1. Okay. All right, so at the top here, I do a little bit of validation. Okay, and then I declare 3 data structures here. So deck, I like using for the queue implementation. So I like deck because you can use it as a stack and a queue. So it's just one data structure to remember, and you can just remember the methods on it. I have a set to keep track of what islands I've visited and which nodes, so we don't visit the same island twice and double count. And then I have this list to first go through the 2D grid and put all of the coordinates in there. Okay, so this is where I start. So I'm going to go through and find the first coordinate, because typically in a BFS, like in a tree implementation, you would add in the root node into the queue first and then kind of continue from there. So following along those veins, I put in, the first one that I could find. So if I go over here to the description, you can see that there could be a 1 here, but it could be a 0, so you can't always guarantee that position 0, 0 is going to have a 1 in it. So I had the idea to go through kind of a linear scan through the entire 2D grid and add all of the ones where we hit land. So I added the coordinates I and j in there, which is awesome. So now at this point I have a list of land. So let me show you that real quick so I can just print out the list. Okay, let's run this so you can see it in the console. Okay, yep, and I need to do, if I'm going to print out the list, yeah, this is not a good way to print that. Yeah, 2 seconds, I'm going to do it. For list, not list, but what is it? I guess it's int array, and we go through the list, and then we can print it out here. Okay, and then we say arrays.toString, just to show you here. Then we got array. Great. Okay. Here we go. And let's see what this looks like. Great. It looks pretty. So I think we're using this example here. So this prints out all of the things that are inside that list, which are all the ones that hit land. So that would be 0, 0 coordinate, 0, 1, 1, 0. See there? Yeah, I thought it'd be ordered, right? So 0, 1. Okay, it looks like this one's different. It looks like we're using this one. Okay, so that's why we have 0, 0, 0, 1, 1, 0, and then we have 1, 1 there. 2, 2, 0, 1, 2, 0, 1, 2, 2, 2, and then 3, 3, and then 3, 4. That makes sense. 1, 2, 3, and 4. Yep. Okay, so that's what we're starting with. You don't actually need this in some solutions I was looking at, but that's what I came up with. It was easy for me to understand. So anyways, that's the list there. And then this is not that print line, Q initial size. Yeah, I don't need those. And then this count is the final variable that we're going to be returning down here at the end. So this is the number of islands that we're going to find through the algorithm. So we have a for loop here that we start with. We're going through the size of the list. So that's going through all of these. And then we have coordinates from the list. So we're getting each of these elements. We're going to pop out 0, 0 right here. And then we have the if set does not contain this coordinates from the list. So you'll probably wonder what this toString array is. So in Java, you need, or the Java set here. It needs the hash code and equals method overridden. So if you put an array in there, the default like hash code and equals, I believe, just like finds the memory location for that array. So it actually doesn't work in the set if you put that in. So you have to put something like a string or an object where you override those two methods for it to work. So it's a little tedious. So I had to like convert it to a string so that I would put like the string coordinate. So it would be literally like 0, 0 as a string in the set. So that worked. But it's probably not super optimal, but it's not too bad. We're not looping or anything. We're just converting it to a string. Okay, and then, yeah. So then if it's not in the set, we add it in. So that's where this first coordinate gets added to the set, or sorry, added to the queue, and then also added to the set. And then if we do find one that contains in the set, then we just continue. We just go to the next one. Great. All right, so while loop here. So this is the typical BFS algorithm. We start with a while queue is not empty. So right now the queue is not empty because it has this guy in there. And then we look at the size of the queue. Right now the size of the queue is just 1. So then we pop out the coordinate. And then we look at the current coordinate. And we check if it's a 1. So if it is a 1, then we hit land. And then we need to look up, left, right, and down to see if any of those are also land. If they are, then we put it in the queue, and we keep iterating until the queue is empty, meaning all you're hitting is water. So, and then meanwhile, we're adding them all to the set here as well. So then each one gets added to the set, so we don't visit it twice. And then right after the queue is empty, we increment the count. Why do we do that? Because when we visit this guy, and then we go to the next one, all of these will get added to the set as long as there's a 1 somewhere up, left, right, or down from it. So we go 1, 1, 1, 1, and then all these are zeros, right? All these are zeros, this one, and this one. So then the queue has nothing left in it because we don't add anything to the queue when it's a 0. So then those get popped. Yeah, so then we pop down here and we say, hey, cool, that's at least one island that we've made. Okay, and then it goes back up to this list where I have a list of all of the land that we have. And then we check to see if there's any more land. And then we go to the next one. So we do queue.offer. So yeah, I'm not sure the runtime, what this adds. It's like an extra little bit because it's kind of iterating through this little bit. So I think it adds to the runtime. That's why it's a little bit slower. Sorry, I'm not too good at the runtime yet or on the complex cases, but I will get better, so bear with me. Anyways, so then we go down here and then we return the count. And as you can see, when I submitted it, it was accepted, so all the test cases passed. So I'm continuing my my climb to become the top software engineering leader. So this is one piece of that. Thanks for all the support, and good luck on your own journey. Thank you.